grade 9 students, and welcome to our Science 9 Adventure class. This is Teacher Shi, and I'll walk you through in this learning adventure. Are you excited? Well, I'm excited too. Come on and let's make science learning fun. For today's lesson, we are going to learn about momentum.
Our learning competency for this lesson is to relate impulse and momentum to collision of objects, and for our learning objectives, define what momentum is and identify the factors that affect momentum.
Let's take a look at this picture. If a cargo truck with a mass of 10,000 kilograms traveling at the velocity of 40 km per hour and a small car with a mass of 2,000 kilograms traveling at the same velocity suddenly lose their brakes and crash against the brake wall, which do you think will be more damaging and why? Do you want to know the answer? It's for you to start the investigation. Kindly open your Science 9 learning material on pages 257 to 259. You have there the list of materials needed for the investigation and the procedures to follow in conducting it. As you follow the procedures, you should have this kind of setup. So these are your initial distances. So we have 20, 40, 60, and 80 centimeters. Now, the stopping distances of the light and heavy toy cars are measured by how far the block has moved after it has been hit by the heavy and the light toy cars. After the conduct of the activity, you have to fill in this table to record the results of your investigation. Guide questions are also given in order to validate your formulated perceptions about momentum based on your observations during the conduct of the activity. Here they are.
Number 1. How will you compare their stopping distances? Number 2. Did the two toy cars immediately stop as they hit the block of wood? Number 3. What do you think happens to the velocity of the two toy cars as the point of release increases? And number 4, if momentum is a measure of how difficult it is to stop a moving object, which of the two toy cars had a greater momentum for the same point of release? And for number 5, how will it be possible for the two bodies of different masses to have equal momentum?
Now that you're done with your investigation, let's try to fill in the table and answer the guide questions you have earlier.
The result data I have here may not be the same with your results. It's not a problem. Obviously, it will give different results since we are using different toy cars and blocks of wood. What have you observed from the stopping distances of the light toy car as the point of release increases? How about the stopping distances of the heavy toy car as the point of release increases? Do you see the difference? I'm sure you do. How about if you compare the stopping distances of the light and heavy toy car? Which one is greater with respect to the initial distances? I'm pretty sure you have your comparison already. Well, let's find out if your observations are correct as we answer the guide questions. Now, let's answer the guide questions to see if you got the correct observations of the data result. Guide question 1. How will you compare their stopping distances? You're right! The stopping distance for the heavy toy car is longer than the stopping distance for the small toy car. How about for number 2? Did the two toy cars immediately stop as they hit the block of wood? What's your answer about this? Correct! The answer is no. The heavier toy car dragged the block of wood along a longer stopping distance than the lighter car did. Guide question number 3. What do you think happens to the velocity of the two toy cars as the point of release increases? You got it right again. The velocity of the two toy cars also increases as the point of release increases. Guide question 4. If the momentum is a measure of how difficult it is to stop a moving object, which of the two cars had a greater momentum for the same point of release? The answer is yes, the big toy car had a greater momentum. And guide question 5. How will it be possible for the two bodies of different masses to have equal momentum? Absolutely, you're correct. The two bodies of different masses will have equal momentum when these two will have different velocities as well.
Alright, so we are done answering the guide questions. So I guess you have already an idea to answer this after we validate your perceptions about momentum. So first, how will you define momentum? And what are the factors affecting the momentum of an object? So what are your answers? Alright, you got it! Momentum is defined as the product of the mass and the velocity of the object. It is a vector quantity wherein its direction is the same as the velocity of the object. Its SI unit is kilogram meters per second. So, how do we express momentum mathematically? Yes, correct. So that would be P is equal to M times V, where P is the momentum, M is the mass, and V is the velocity of the object.
A sport team that is on the move has the momentum as well. If an object is in motion, then it has momentum. That is why momentum is also defined as mass in motion. If momentum is the product of mass and the velocity of the object, what are the factors affecting momentum? You're right. Mass and velocity are the two factors affecting momentum. No more, no less. Moving objects have velocities which can be measured directly or indirectly. For stationary objects where velocity is zero, the momentum is also zero. Now let's have some sample problems. Calculate the momentum of the given objects. A basketball having 2 kilograms mass and 6 meters per second velocity moves to the east. So, what are the given in this problem? And what are we looking for in this problem? Yes, correct. The given in this problem are mass of basketball, which is 2 kilograms, and its velocity, which is equal to 6 meters per second. And we are looking for the momentum of the basketball. So, how do we solve for the momentum of the basketball? Have you gotten the answer? Let's see if you have the same answer as mine. Using the equation P is equal to M times V, we simply substitute the values of mass of the basketball and its velocity. Therefore, we have P is equal to 2 kilograms times 6 meters per second. Multiplying these values and units, 2 kilograms and 6 meters per second, so we have 12 kilograms meter per second as a result. Very easy, right? Now, let's try another sample. A car having 15 meters per second velocity and 1,500 kilograms mass moves to the north. What is its momentum? So, what are the given in this problem? And what are we looking for in this problem? Yes, very good. Correct. The given in this problem are mass of car, which is 1,500 kilograms, and its velocity, which is equal to 15 meters per second. And we are looking for the momentum of the car. So, how do we solve for the momentum of the car again? Have you gotten the answer? Let's see if you have the same answer again. Using the equation P is equal to mass times V, we simply substitute the values of mass of the car and its velocity, the same as what we did in our first problem. Therefore, we have P is equal to 1,500 kilograms times 15 meters per second. Multiplying these values and units, 1,500 kilograms and 15 meters per second, so we have 22,500 kilograms meter per second as a result.
So I guess you're good enough to try out some exercise problems, right? Okay, so here it is.
Given the following data, complete the table by solving the momentum using the formula P is equal to m times v. Alright, I guess you've finished now filling out the table. Let's see if you got the right answers. So for the bird, its momentum is 0.54 kilograms meter per second. For the basketball player, we have 500 kilograms meter per second. For the bullet, we have 2.4 kilograms meter per second. Then for the baseball, its momentum is 4.2 kilograms meter per second. Finally, for the frog, we have 2.28 kilograms meter per second. Alright, we have now completed the table.
Did you get the same answers? Oh, that's good! Amazing! Well, let's do a wrap-up first before you do your assessment.
So, if you're looking for momentum of the object, you're given our mass and velocity of the object. You're going to use the equation P is equal to m times v. If you're looking for the mass of the object, the given will be momentum and velocity of the object. You are going to use the equation m is equal to momentum divided by velocity. Lastly, if you're looking for the velocity of the object, your given are the momentum and the mass of the object. So you're going to use the equation velocity is equal to momentum divided by mass.
So there you have it, students. We're done with our learning adventure about momentum. Congratulations for a job well done all throughout our lesson. So I guess it's time for us to check your understanding. Are you ready? Well, it's assessment time. Good luck and enjoy.
Direction. Answer and complete the sentences based on the concepts you have learned about momentum. Which has more momentum? A huge truck that is not moving or a small toy cart that is moving? A moving car has momentum. If it moves twice as fast, its momentum would be blank as much. Two cars, one twice as heavy as the other, moves down a hill at the same time. The heavier car would have a blank momentum. Answer the following problems using the proper format. A skateboard is rolling at a velocity of 3.0 meters per second with a momentum of 6.0 kilogram meter per second. What is its mass? So that is it for our science class adventure today. I hope you enjoy and learn a lot. Let me end this video with this quote. Always remain open to learn new things. If you don't learn, you don't grow. God bless and stay safe always. Again, this is Teacher She, your science adventure guide. Bye for now.